Okay, so we're going to divide polynomials when our a value, so that's the coefficient of the highest variable term, is greater than 1. We're used to doing it where this value would just be 1 or there's nothing there representing 1, right? But because this is 1, one of the ways that we found factors to a large polynomial is we have to find something that creates a 0, right? So normally we would take factors of our last term. But in this case, because this is no longer 1, we have to multiply the two of the terms together. Before, when this was 1, well, 1 times the last term was always whatever the last term was, so we just found factors of that, okay? But because this is not 1, we're going to multiply the two of them. Or sorry, divide the two of them. Said that backwards. So, when we divide, we have our negative 10 and 6. And the same thing still worked. If it was 1, 10 divided by 1 was still the same number there. So, factors of negative 10 over 6. What we're going to do is keep them in fraction form. So sets of factors. Well, there's lots of sets of factors. We could do this as negative 10 over 1 and 1 over 6, right? That would be negative 10. That would be what that factor is. And we'll pull this page down just a little so that we can write a little more information. So this is one pair. We have to find several sets of pairs, okay? And then obviously we could do the vice versa when the negatives are different. So here's one set of factors we could use. Another number that goes into 10 is 2. So we could use 2 over something and 5 over something. And that could still be 1 and 6, right? Because we multiply those across. Is this making sense so far?
Yeah.
Yeah? Okay. So here's the set of factors. There's a lot of different ones. We could also use 2 and 5 again. But this time when we break 6 up, 6 can also be 2 and 3. Or we could also have 2 over 3 and 5 over 2. Okay? Because in this case, that's just 1 and 5 over 3. Here we have these two. 2 and 5, 2 and 5, 3 and 5. And then I think the only other one after this would be 10 over 6 and 1 over 1 in this one. Okay? So these are essentially factors of it. So we can test these out, but we're going to actually look for a pairing that creates zeros. Okay, so both of the factors would create a 0 in here. When I put 10 in here, I'm going to get 4,000. I'm looking at something that's probably not going to work with the 10s. We'll see if we can quickly bring it up. But 10 to the power of 4 times 6. All right, so we're looking at 60,000. Okay. And then 10 to the power of 3 times negative 17. What the heck happened there? 10 to the power of 3 equals times 17 negative. Okay, that's 17,000. So what did we say? 60,000 plus that? We're at 43,000. I really, the rest of this isn't going to equate to the rest of 43. So because this factor didn't work here, this pairing doesn't work. So we're going to go through pairings. This would be the number 2. Okay, always try to find a pairing where a number might be really easy to go through and then test the harder one first. So we have 2 essentially. So let's put 2 into this and see if that creates a 0. If it doesn't, then we know that pairing's not going to go for us here. That's going to be 2 to the power of 4 times 6. Okay, 96. So let's keep that in mind.
Okay.
Write that down. I'll write it down here. So we have 96, and then we're going to have 2 cubed times 17 negative 136. Okay, and then 2 squared is 4 times 7 is 28. Minus 2 minus 10. So let's put that together and see if that creates one of our zeros. So we have 96 subtract 136 plus 28 subtract 2 subtract 10. Well, it didn't look like it works, okay? Anyways, we go through testing these. What we discovered, or what they've essentially told us when we go through them, that the one that's going to work here is going to be this pairing. And it's specifically when this is negative. Okay, that's the other thing we had to check out. Because this is negative, one of the pairs had to be negative and one would have to be positive. So we'd have to test that all out. So that's the idea of testing. So now that we have this, Okay, what we're going to do is going to create a quadratic out of that pairing. Okay, so I'll scroll down. And the way I'm going to create a quadratic out of this pairing is think of it like this. We have x. Because that was minus 2 over 3, it becomes plus 2 over 3. Okay? And the other one is x minus 5 over 2. Okay. Well, we want these to not be fractions. So in order to really do this, think of this like another way we could have put this is we could have put them equal to 0, essentially, okay? So we will be reversing these. So what that means is we were looking for when our k values here, when we set these normally up, this will essentially become 3, or sorry, it's negative, yeah, so it'll be 3x plus 2, okay? And 2x minus 5. And the reason that works is because when that is set equal to 0 and we reverse it, the 2 would move over, so we get 3x is equal to negative 2. And then we divide by 3, x is equal to negative 2 over 3. So that's how we reverse it. But this is the pairing that we're looking for. Okay? We essentially took the number on the bottom and made it the coefficient beside the x. Okay? And the same thing would have worked here if we'd set that equal to 0 because both of these created zeros, right? When we brought 5 over, it become positive 5, 2x, and we divide by 2, x is equal to 5 over 2. And if you notice, that's the exact pairing we had above, negative 3 over 2 and 5 over 2. Okay? So all we've done is put them as brackets so that we can make our factor. 3x plus 2 and 2x minus 5. Okay? Well, we want this to be in standard form. Right now, this is in our factored form. So to put it into standard form, we FOIL. Okay? So when we FOIL this, we're going to get 6x squared minus 15x plus 4x minus 10. So we're going to end up with 6x squared minus 11x minus 10. You see how that's the exact thing that you got here? Yeah. Okay, so that's what our factor is. It's a quadratic, so we can't use synthetic. You can only use synthetic division when we have a linear divisor. So we now take this and we actually divide the original equation, which in our case was 6x to the power of 4 minus 17x cubed minus x minus 10. Okay? Now we do the long division for this. Well, when we look at it, what can we multiply 6x squared by to make x to the power of 4? And that's x squared. Okay? So because there's 3 terms, I actually go to the third term here. I put x squared above it because I'm going to be multiplying x squared by all 3 of these terms. 1, 2, and 3, and then subtracting. Okay? Well, x squared times 6x squared is going to give us 6x to the power of 4. That works. When we multiply by negative 11, we'll get negative 11x cubed. And when we multiply by negative 10, we'll get negative 10x. We then subtract these numbers.
I thought they're supposed to be like in this, you're supposed to leave like...
Oh, there is a squared. Oh, good eye.
Oh.
Yeah. So, because this is 4, 3, and then straight down to 1, okay? Because that's straight down to 1, and that should have been squared. That should have tipped me off. We actually have to make room here for the squared. So in other words, I didn't notice that. Oops. Leave that and we'll erase it. We have to represent the squared with a 0. Okay? Yeah. So we can add or subtract 0x squared, and then this was minus x minus 10, right? We've included the squared because we have to go down in an order. Okay? It has to go 4, 3, 2, 1, and then none. So we have to represent it, and the only way to represent something that's not there is to multiply it by 0. Okay, so then this again should be 10 squared. Good, because I did that multiplication wrong when I said it out loud. X squared times negative 10 should be negative 10x squared. And the only way we can subtract is if our actual variables are the same power. So that's how we know if we've made an error, if our variables are not to the same power. So when we go to subtract, this will cancel out. This will become negative 6x cubed. Okay. This will become positive 10x squared. And then we bring down the x. So subtract x. Same idea. what can we multiply 6x squared by to get negative 6x cubed?
Negative x.
Yeah, negative x. And same thing again. So this will give us negative 6x cubed. This will give us positive 11x squared. And this will give us positive 10x. Now we subtract these numbers. The first ones are going to cancel out. Right? When we subtract this, we're going to get negative x squared. And when we subtract that, we're going to get negative 11x. Is that right? And then we'll bring down the negative 10. Okay. Now, if you notice, we're unable to, oh, sorry, no, not that we're not able. We can get a fraction here. Because this is a 1 and this is a 6, we're going to have to actually divide by a fraction. Okay, we have to turn the coefficient 6 into 1. So in other words, we're going to have to multiply by 1 over 6. Okay, 1 over 6 when multiplied by 6 will give us just 1. Okay, so the coefficient we're going to use is 1 over 6, and it's going to have to be negative. So we're going to be times negative 1 over 6. When we do that, that'll give us negative x squared. Here it'll give us a fraction, positive 11 over 6x, and positive 10 over 6. Okay, and then we can do our subtraction. This term will cancel, and now we're working with subtracting fractions. Okay, so this again becomes a little more complex. We got to put this as a fraction over 6. So I'm going to turn the negative 11 into negative 66 over 6x, and then we're subtracting 11 over 6x. Works out fine. We're going to get over 6, negative 77 over 6x. And for our other one, again, I got to put the 10 over 6. So I'm going to get negative 60 over 6, and that's going to be subtract 10 over 6, which will give us negative 70 over 6. Okay, so this will be negative 77 over 6x minus 70 over 6. Okay, so when we go to actually piece this all together, when we divide it, this will be one set of factors, x squared, or we're to write it out, 6x squared minus 11x minus 10. Another bracket will be our answer up here, x squared minus x minus a sixth. And our remainder is actually minus 77 over 6x minus 70 over 6. Okay, that becomes our remainder. It's actually two terms, a linear almost, you could say. We're not multiplying, we're adding or subtracting it in this case. And then from here, we could possibly use the quadratic equation to factor both of these, okay? And that would tell us if there's actually more, if they are factorable, right? If there are any factors, and because this is a quadratic function, that means it's going to turn 1, 2, 3 times, okay? Which means if the x-axis is here, we could have 1, 2, 3, 4 different points. So if we were to factor this and get 2, and factor this and get 2, that means we'd have 4 x-intercepts, okay? And that's the idea to it. Maybe one of these is not factorable, and it's something that maybe looks like this, 1, 2, and goes like that, and it only crosses twice, right? And then the other terms are below, or the opposite idea, the other terms are above the x-axis, something like that, okay? So a lot of steps to this one, especially the hardest part is figuring out what our factors are going to be if they haven't given it to us.